Okay, for the 10.1 quick check, we're asking for the types of bonds. So the types of bonds be metallic, nonpolar covalent, polar covalent, and ionic. So looking at this, we say, okay, C and O. So what we have two nonmetals. They're in the upper right corner of the periodic table. And oxygen is considered one of the strong nonmetals, while carbon is a weak nonmetal. So when we have a weak and a strong, then that's going to be polar covalent. And the way we're going to write that is we're going to say we have a C bonded to the O. And because it's polar, the strong one is going to be a little bit negative, and the weak one is going to be a little bit positive. So that's what we mean by the representation. When we have magnesium and magnesium, those are two metals, so it's going to be metallic, and we just have to say magnesium, magnesium. If we have H and S, okay, these are both nonpolars. Okay, I'm sorry, they're both nonmetals. H is a weak nonmetal, S is a weak nonmetal. Because remember, the strong nonmetals, only these four that we have to worry about, and that's N, O, F, and Cl. Okay, so both of these are neither one here. Back here, oxygen was one strong. So weak and weak, that's going to be nonpolar covalent. So we're going to say H and S, and we don't have to draw anything. We only have to write things as far as representation, the charges, if we get ionic and if we get polar covalent. Okay, then we have Mg and O. Okay, well here we have a metal and a nonmetal, so that's going to be ionic. And when we write our bonds, okay, then we're going to say, well, the oxygen, since it's the nonmetal, is going to become full negative, and this guy will be some kind of a positive. Now, we don't have to say +2 and -2, although it is. We just say it's plus and minus. S and O, okay, both are both nonmetals, but here's O again as a strong nonmetal, so this is going to be polar covalent. And when we get our S and O bonded, the oxygen is going to be somewhat negative, and the sulfur will be somewhat positive. And finally, Fe and S, we have a metal and a nonmetal, and a metal and nonmetal is going to be ionic. And so when you write those, we're going to say the nonmetal is going to be negative and the metal is going to be positive. So that's the first part. Okay, next part. Draw Lewis dot structures for each of the following atoms or ions. Okay, we'll look at carbon. Carbon on the periodic table is in family 4. So we're going to get 1, 2, 3, 4 valence electrons just like that. Okay, potassium is in family 1. It gets 1 dot. Sulfur is in family 6, so we put 1 on each side and start doubling them up, so we get 6 like that. Oxygen, now oxygen starts with 6. It's an ion, and it's a 2- ion, which means it has 2 extra electrons, so it ends up with a full octet, 8 electrons. And aluminum, okay, it usually has 3, but because it's 3+, that means it lost its 3 electrons, so it gets no things at all, no dots, no valence electrons. Okay, who is going to be isoelectronic, has same number of electrons as argon. Okay, so the one right after argon is potassium, and the one right after that is calcium. One right before argon is chlorine, and the one right before that one is going to be sulfur. Okay, so if they were all neutral, okay, then argon would have 18 electrons, potassium would have 19, and calcium would have 20. But when it forms a 1+ ion or it forms a 2+ ion, okay, those are going to have 18. Now the chloride, okay, normally has 7, but it gains 1 electron and it has 18. And sulfur normally has 6, but it gains 2 electrons. So all of these ions and elements all have 18 electrons. And we say that they are isoelectronic. Now, last one here is let's do an ionic compound. Okay, so if we have potassium and oxygen, well, what happens is potassium has 1 electron, oxygen has 7 electrons, and another potassium has 1 electron. And what happens is that this electron is pulled into the more electronegative oxygen, and this one also is pulled into the more electronegative oxygen. So what do we end up with is we get a potassium ion. So I draw it like this, no valence electrons. And then we'd have an oxygen with 8 valence electrons. And then we'd have another potassium with 0 valence electrons. And that's how we would write an ionic compound. And that is the quick check.